Welcome to the UGC lecture series. This is a series called the EPG Patashala, and here we are talking about the course called data structures, and we are going to begin with the introduction. This time we are going to talk about data structures in a different way. We are going to talk about the abstract data type perspective of data structures. These are the people involved in the creation of this lecture series. The learning objectives of this particular introduction module is to appreciate programming perspective, to understand programming design principles, to know about the different data types and to understand abstract data types, which is something new. You may have already studied the subject data structures, but we are going to look at it from an abstract data type viewpoint, and the major topics we are going to or the word keywords associated with this are data types, abstraction and encapsulation. So, let us first look at introduction. As you know, as a computer science person, programming is very important, and programming is nothing but problem solving through the use of a computer system. And one thing that we have to understand is computer programming is not magic. You cannot make a computer do something if you do not know how to do it yourself. You are just instructing the computer to do the things, but it would do it in a much more faster way. So, what are the tips you can look at when you are designing a program? Find out as much as you can from whoever wants the program, reuse what has been done before. This is the basic concept that has now come up in computer science, reusing. Computer scientists follow the maxim that you should not reinvent the wheel. So, and you have to design your program such that it can be reused later. And another concept is the breaking up of the complex programs into sub problems. So, how do we go about this? You find out what is known about the problem, talk to the presenter, the person who wants the problem, determine what has been done before and what has succeeded and what has failed. After that, you go about your programming. So, before we go further, we will talk about what are called as preconditions and postconditions. One way to specify the requirements for developing a program is a pair of statements about the function, which is called precondition and postcondition. What is this precondition and postcondition? Precondition statement indicates what must be true before the function is called. You can call this function only when this condition is true, and postcondition is the statement that indicates what will be true after the function has been has finished its work or has been finished. So, this is what is precondition and postcondition. If you have your precondition and postcondition properly, you can do programming and you can use all the functions, and reusability also will be good. Now, let us take an example of right square root double x, and we are giving the precondition that x should be greater than or equal to 0, and the postcondition is the square root of x will be written as standard output. Now, which of these function calls meets the precondition? So, if you look at this, right square root minus 10, right square root 0, right square root 5.6. Now, the precondition says that x should be greater than or equal to 0, and in this the first call right square root minus 10 does not satisfy the condition precondition, while the other two satisfies. So, you have to be very careful of what the precondition is, and because to satisfy the precondition, I mean based on the precondition only the function is developed. That means, we have to make sure that the precondition is always valid. So, the programmer who calls the function is responsible for ensuring that the precondition is valid when the condition is called. So, the postcondition becomes true at the function's end. That is it. So, the programmer who calls the function should see that the precondition is satisfied, and the programmer who is writing the function should ensure that on the preconditions being valid, he has to ensure that the postcondition becomes true at the function's end. This is one of the basic rules of writing a program, but careful programmers also follow additional rules. What are the additional rules that they follow? When you write a function, you should make every effort to detect when a precondition has been violated. So, it is up to the programmer to check whether the precondition is valid, and if you detect a precondition, you have to give an error statement, otherwise it will be called and that will cause a disaster. So, what are the advantages of using preconditions and postconditions? What are the advantages? So, without cluttering up your thinking, it gives you the details of how the function works, and at a later point you can implement the function in another new way. As long as the precondition and postcondition are satisfied, you can write and implement your program. It does not make any difference to how the function is called. So, based on these precondition postcondition, we have some design principles. What are the design principles of programming? The design principles of programming are abstraction, encapsulation, modularity and hierarchy. So, let us take each of these principles one by one. What is abstraction? Abstraction is the process of determining the relevant properties and features of an object while ignoring the non-essential details. So, you have to find out what is essential, the relevant properties and features essential to that particular object. We are now talking about something called an object, do not worry, we will come to that later. I mean how it goes into programming, but we have to ignore the non-essential details. This is also very important. So, relevant properties are defined basically on how the project is used, I am sorry, not project, object is used and manipulated. For example, an audio salesperson views a car from the viewpoint of only the selling features, while a mechanic will view the same car from the standpoint of the systems that require maintenance. So, this is the idea of an abstraction. So, the same object can be viewed by two different people from two perspectives, ignoring the other perspective. So, next is encapsulation. We said there are different principles, one is abstraction, the next is encapsulation. Encapsulation essentially means you separate out the external and internal components. Only external aspects of the object need to be visible to other object of the system. What is internal to this object need not be known by external other objects. Internal objects are details that should be not affect, if you do not want others to know the internal, it should not affect other parts of the system. Hiding the internal aspects of an object means that they can be changed without affecting other system parts. Okay. So, that is the importance of encapsulation. You are encapsulating the external, I mean you are dividing the object into external and internal and showing only the external to the other objects and hiding the internal. So, this is what is called the concept of encapsulation. Next is the concept of what is called a hierarchy. Now, hierarchy means this is an example of a management hierarchy, which says it is based on only the relationship of who reports to whom. For example, president, you have vice president, treasurer, vice president of sales, operations and research, all reporting to the president. Within the vice president for research, you have chief scientist and patent and so on. So, this just tells you a typical, this is a particular hierarchy. You can have different management hierarchy like general manager, sales manager and so on. So, what is essentially hierarchy? Hierarchy gives a ranking or ordering of the objects, that is what is hierarchy, right. So, a useful way of ordering the abstraction is from the most general to the least general based on some relationship between them, and this is called a hierarchy, that is arranging it from most general to the most specific. Now, what are the principles of hierarchy? Hierarchies can help us understand complex objects, because we are starting from the general and going to the most detailed one. Hierarchical ordering based on natural relationships is called a taxonomy. For an example of a taxonomy could be, for example, you can have living beings, human beings, adult male, then you can have males, then you can have adult male and boys and so on. So, this is a typical natural order. You can have also trees, mango trees and specific mango trees like that. So, specific means Malgova or whatever you want. So, hierarchical ordering based on natural relationship is called what is called a taxonomy. This makes all the abstraction easier to understand. We spoke about three principles: abstraction, encapsulation, and now we are coming to hierarchy. Now, hierarchy makes abstraction easier to understand, because it exposes the relationships of the characteristics behaviors they have in common. So, between general and specific there will be some characteristic behavior that is common. For example, consider a taxonomy of musical instruments that organizes the instruments by how they produce their sound, by wind or whatever, string instruments, wind instruments, but they are all instruments, they are all musical instruments. So, that is common characteristics. Now, let us look at, so that we have covered the concepts of abstraction, encapsulation, hierarchy, we have considered. Now, let us look at some important data structures. So, there are some important data structures like linear structures, example array which is fixed size, linked list which we are only talking about linear structures, linked list which is variable size, stack which adds to the top and removes from the top, queue which adds to the back and removes from front, priority queue you can add anywhere, but it removes only with the highest priority. So, now with that data structures introduction, let us see what is a data type. Okay. What is a data type? A data type is a set of objects. Remember, we had before this we had spoken about some of the characteristics of objects. Now, we are saying it is a set of objects, each called an instance of the data type. Some objects are sufficiently important to be provided with a special name. So, you can have a set of objects, integers for example is a set of objects, that is the special name. Now, what is a data type? A set of operations can be realized via operators, functions, procedures, methods and special syntax depending on the implementation language. Each object must have two aspects. One is a representation, not necessarily known to the user of the data type, but it should have a representation, and each operation must have some associated with the data type must have a. So, a data type consists of a set of objects and a set of operations, and the data objects has to be represented. So, that is the representation, and each of the operation associated with that data type has to be implemented, and this also need not be known to the user. So, there are basically two varieties of data types. One is called opaque data types and the other is called transparent data types, opaque data types and transparent data types. So, opaque data types in which the representation is not known to the user. So, then he can just use the data type and assume that everything will be done as he wants, as has been specified by the data type designer. Transparent data types in which the representation is known to the user. By knowing the representation, the user can use it more profitably. That is, the encode is directly accessible or modifiable by the user. Which one do you think is better? Just think about it. So, sometime opaque means reusability is good, transparent means efficiency is good, just think about that aspect. So, C++ is a typical language that you have all heard about. And what is the facilities available in C++ to create opaque data types? You can think of that. Remember, opaque data type is not, the implementation is not known to the user. So, that is data type. Now, data structures is a systematic way of organizing and manipulating the data. So, a data structure structures data, usually more than one piece of data, and you should have some legal operations defined on the data, and the data must be joined together, means there should be a set of thing in some representation, and that is called a collection. So, when you talk about data structures, there are two aspects again, the data organization and the functions or operations that manipulate the data. So, data structures conceptualize conceptual and concrete ways to organize data for two things: efficient storage, that is the representation aspect of it or the organization aspect of it, and efficient manipulation, which is the how efficient the operations on that particular data structure is. Data structures are used basically in the design of efficient algorithms. So, there these data structures, if they are efficiently stored and efficiently manipulated, they affect the efficiency of the algorithms that use those data structures. Now, we will go to certain certain issues why opaque data types are better. So, the idea is that, remember, in opaque data types both the organization as well as the manipulation is hidden from the user. So, this means the representation can be changed without the knowledge of the user. The user can continue to use the data type. Forces the program designer to consider the operations more carefully, because associated with each data type there are only some operations. So, you should use the choose the data type correctly, and it encapsulates the operations also, because it is being done, the implementation is being done separately. It is not incorporated into the program. So, it is done in an encapsulated manner, external and internal. Remember what is encapsulation? Internal and external aspects are separated. Unless you do that, you cannot have an opaque data set. Allows less restrictive designs which are easier to extend and modify, because you just are bothered about the interface. I am not using that word. The post condition and precondition specified, you have to keep track of. Design always done with the expectation that the data type will be placed in a library of types available to all. So, that is how you will implement the data type and design it. Now, abstract data types. Now, we are coming to the main topic of this lecture, which is the abstract data types. So, that is the main thing that we are talking about, and we have finished the introduction part of the lecture, and we are talking about abstract data types. Now, when we talk about abstract data types, we have to talk about the concept of abstraction. An abstraction is a view or representation of an entity that includes the most significant attributes. Remember, we said that the non-essential part of the particular entity is not considered, only the essential features and attributes are considered. So, that is the abstraction. This concept of abstraction is fundamental in programming, and always it is fundamental to programming. So, programming languages that support process abstraction, not data abstraction. Process abstraction has always been part of programming, the subprograms. Programming languages since 1980 has started to support both data abstraction also, and that is what we are talking about here. So, what is this concept of abstraction? The concept of abstraction means you know what a data type is to do, you know very clearly this data type does all these things, input this is what I will expect as output, but how it is done is hidden. That is the basic concept of abstraction. So, the abstract data type is a user defined type that satisfies the following conditions. When do you call a data type an abstract data type? The representations and operations that are associated with that particular type are defined in a single syntactic unit, that is the operations as well as the representation is all available in a single unit, syntactic unit. The representation of the objects of the type is hidden from the program units that use these objects, that is the implementation and representation is not known to whoever is using these objects. So, the only operations possible, which means the only operations that are possible to do with that data type is that provided in the definition. The definition gives these are the operations available for this data type, only those data type you can use. So, what is the advantage of the first condition? The first condition is that the representation and the operation associated with the data type is put in a single syntactic unit. So, what is the advantage of that? The program organization, and you can do a separate compilation, everything associated with the data structures held together. Advantage of the second condition, remember what the second condition is? Second condition is the representation object is hidden. Okay, so, advantage is reliability. By hiding the data representations, the user code cannot directly access the objects of that type or depend on the representation, allowing the representation to be changed without affecting the user code. So, please remember this, I have a user code, that user code will be using these data types as a black box. So, this data type, the operations that you can do with that data type is defined to you. So, you have to use that. Now, you cannot go and interfere in the representation of the data object, you can take advantage of all that. That makes it independent, and you can change the implementation of the data type without affecting the user code, as long as you keep the precondition and post conditions the same. So, abstract data type ADT in short it is called, is some data. So, what is it finally? It is some data associated with a set of operations. So, the mathematical abstractions available in programming are integer, boolean. So, you know in a boolean you can only get true and false values, and associated with boolean you have some operations, integer you have some operations. This is a built in data types as they are called. So, the basic idea is a logical view of the data objects together with specifications of the operation required to create and manipulate them is what is defined. So, you write once what is the data type and what are the operations associated with it, and what do? You use it as many times as possible. Now, any changes are transparent to other modules, that means they are not the user code that uses this, nothing is available to him. Okay. He just uses it, the implementation aspects or any changes you do are not available or not accessible to him, it is hidden from him. When you describe an algorithm, you can use a pseudocode without using the properties of the programming language. Similarly, when you describe a data structure, you can define it as an ADT, and you can use the data structure in your user code without knowing what the representation is or what the implementation is. So, again, since this module is basically about abstract data type, what does abstract mean? It is come from the Latin word to pull out the essentials, that is you are only going to talk about the essentials, and you are going to hide the details. Abstraction emphasizes essentials and defers the details, making engineering artifacts, that is these data structures, easier to use. So, an abstract data type has a declaration of data, a declaration of what are the operations possible, and an encapsulation of the data and operations in a single syntactic unit. So, for example, you have what are called as primitive data types and abstract data types. Primitive data types are provided by the programming language, for example, integer float which the programmer can use, while the abstract data type is again provided by a programmer, where he has an interface and he has the implementation. These are the implementation of the operations, and this is the data has a representation, but this is taken as a single unit and can be used by him or any other user code once this is available in a library. So, again to just re-emphasize the definition of an abstract data type or ADT is a type for encapsulating related data, is abstract in the sense that it hides the distracting implementation details, and it is a perfect programming mechanism to create ADTs, because their internal details are encapsulated. So, let us consider some examples of ADT. The set ADT, the set ADT is a set of elements. The operations can be union, intersection, size and complement. So, what do you do? When you are implementing an ADT, you have to take the ADT, define the set with its own representation, and you have to decide these are the operations I want. You can have less number of operations or more number of operations, but you have to define these are the operations that are available for this particular data, abstract data type. So, here we have said union, intersection, size and complement. Similarly, you can define what is called a Q ADT. Again, it is a sequence of elements, and the operations can be create empty queue, insert, examine, delete, destroy queue. You can have different types of operations associated. So, now one thing you have to remember is two ADTs are different if they have the same underlying model, like but have different operations associated with it. So, if you previously we have defined a set ADT which says that it had a union, intersection, size and complement, but if now you are defining a set ADT which has only union and find, then that is called a separate ADT, because an ADT is not isolated from its operations. You have the ADT defined and you have the operations associated with it, and you can use it only as a single syntactic unit. When we are talking about ADT and data structures, obviously we are going to talk about the implementation of the data structures. Now, the appropriateness of an implementation depends very much on the operations that have to be performed. So, as a designer and implementer of a data type, okay, abstract data type which is going to be used by you and others, the choice of the representation depends on the operations that you want to support. Okay. So, and how you represent it, So, the next question is why ADT? Now, this allows implementation to be, we have already told this is a summarization of what we are trying to say. It allows implementation to be changed without violating the ADT definitions. So, you can, as long as you do not violate the definitions, you can change it, and it gives a standard list of structures to use and study. So, once it is available, it is available, you can use it in different ways, and it is a building blocks and tools for user code. It is a foundation of the famous object oriented programming, and the concepts associated are abstraction, encapsulation, modularity and hierarchy, which we have already seen. So, what are the pros and cons, the advantages and disadvantages? Implementation of ADT is separate from its use, that is advantage. It is modular, one module for one ADT. So, it is easier to debug and easier for several people to work on it simultaneously, because the interface or the preconditions and postconditions do not change. Code for ADT can be reused. If once the ADT is available and you want to use that ADT, you can use it in different applications, and it is in information hiding. It is a logical unit to do a specific job. Implementation details can be changed without affecting the user program. This is what we have been again and again stressing in this lecture. Allows rapid prototyping. So, suppose you have to do some prototype program, you can use it as a basic ADT and then fine tune it later to create a new ADT later if you want, but there is some loss of efficiency. Now, let us look at the modularity aspect of it. It keeps the complexity of a large program manageable by systematically controlling the interaction of its components. So, see, any programming program that you write would obviously use a number of data structures. Now, you have a library of data types that you can use, abstract data, set data type, Q data type, which you can use, and so it becomes manageable, because here you are looking at the logical flow of the program which uses these data structures, and you are not bothered about the implementation of these data structures. And it also helps you to isolate the errors, and it eliminates redundancies, because once you have implemented an ADT and the same entity you want to use it for different parts of your program, you can do that. And so, such a modular program is easier to write, easier to read and easier to modify. So, and then the procedural abstraction, it separates the purpose and use of a module from its implementation. So, implementation is done separately. Once you have the implementation, you can, you can write the program without the implementation and then call the library later. So, a module specification should detail how the module behaves and identify the details that can be hidden within the module. So, information hiding is another important concept when we talk about abstract data type. ADT hides the implementation details of the operations and the data from the users, makes these details inaccessible from outside the program. So, once you have defined a ADT, the implementation details are not available to the outside world. Users can use the operations of an ADT without knowing how the operations are implemented. So, for example, you have a deck of playing cards, you have a set of index cards containing contact information and you have telephone numbers stored. You can use it without knowing how actually it is stored, how it is sorted and things like that. So, what is data abstraction trying to achieve? It asks you to think about what you can do to a collection of data independently of how it is done or how you do it. So, it is also making you think in a design perspective. I want this ADT. Now, you will choose that ADT only if it is reusable in a number of places, and you will not unnecessarily put a simple with 2 operations, later on you need a third operation. So, like that. So, the ADT will tell you what you can do with the set with something, but not how you can do it. Allows you to develop each structure in a relative isolation to the rest of the program. So, you can concentrate on the implementation of the data structure, and how it is used can be looked later on. It is a natural extension of procedural abstraction. Procedural abstraction was subprograms, data abstraction is this type of abstract data types. So, operation of the ADT can only be done, whatever operation you can only do it by calling the appropriate function associated with that ADT. So, you will have the ADT and the operation, you can only call it in that way, and nowhere does it tell you how that particular operation is implemented. The definition of the type and all operations of that type can be localized in one section of the program, and after you do all this, the ADT can be treated like a primitive data type, just like an integer. So, you have no concern of its implementation, like how you treat an integer, how you treat a boolean, you can treat the data type. So, that is the idea. Now, let us see how to design a data type. In this course, we are talking not about the usage of the abstract data types, we are talking about how abstract data types are represented and implemented, and we will also be looking at how these implementations are chosen depending on the operations associated with the data type. So, the design of a data type should evolve naturally during the problem solving process. Okay. So, questions to ask when designing a abstract data type or ADT is: what data does a problem require and what are the operations that the problem requires? For a complex data types, for example, the behavior operations must be specified using axioms. So, for example, you can say you create a list of particular size and start with the size of 0, like that you can say. So, you have to design that. After that, you have to design the data type, and once you have designed the data type, next is the step is the application. You develop a real or imaginary application to test the specification, because what you are doing essentially for a abstract data type is you are specifying that data type. So, missing or sometimes when you design it, you may miss an operation or you may not do an operation properly. For example, you may not give the correct output which is necessary for your program. So, that side effect can be found by trying to use the program or the specification. The third step is of course the representation. You have to choose the representation depending upon what the operations are. So, you have to implement the operations and then you have to test, debug and reuse. So, the basic is design, then look at it how it is going to be applied, revisit the design, then come back and implement. What are the language requirements for ADTs? It is a syntactic unit, it requires a syntactic unit in which to encapsulate the type definition, and you have to have a method of making type names and subprogram headers which are visible to the clients while hiding the actual definition, and some primitive operation has to be built into the language process. So, typical operations are, when you take any data type, some operations are anyway necessary: add data to a data collection, remove data from a data collection, ask questions about a data in a data collection. We will be looking at these 3 major operations as we go along. Whatever the data type, these 3 are necessary: adding, deleting and checking some values. The summary here is that we have discussed important programming design principles. We have understood abstract data types, different data types and especially abstract data types and their usage, some of the characteristics of abstract data types and listed the various data structures. Basically, in this course, we will be talking about abstract data types of typical data structures and looking at how the representation and implementation is decided based on what operations has to be done with that particular data associated with that particular data type. Thank you.